Hi, everyone. We're here today to talk about the exciting topic of generative AI safety and trust. I'm Amy Stapleton. I work for a company called Opus Research. We do consulting and research around specifically what we used to call conversational AI. These days, it's more about generative AI, large language models. And I specifically wrote a little report at the end of last year around the topic of trust and safety with generative AI and some things that companies need to think about.
I'm Anthony Scodary. I'm co-founder, co-head of engineering at Gridspace.
Cooper Johnson, voice user experience designer at Gridspace, which covers a lot of things, conversation design on up to thinking about the best ways to align our current Gen AI technology with particular use cases.
So in my little role playing that I'm doing here, I'm going to put on my first hat is going to be that I am part of a company that does certain kind of healthcare procedures, and I would like to automate the follow-up process with some of the patients after they've completed that regimen of whatever it is, because right now it's taking up a lot of time and effort to follow up with an actual employee calling those people. So my concern is, I've used ChatGPT maybe in some of my own stuff that I've been doing, and I know that there are a lot of great possibilities, but I'm also hearing all of these very concerning issues that some companies are having where they deploy some kind of a voice bot, and then the voice bot, it says things that, it makes stuff up. It gives out incorrect information. And so as a person that's working in a company where it's highly regulated, there's a lot of things you want to make sure are very strictly handled. I'm looking kind of like at the risk reward balance here. Is there enough reward for me using this kind of voice agent in the example situation that I'm talking about? Or is there too much risk? And so just my first question, I guess, is should I even be talking to you guys, or is my situation like too risky?
That's a great question, Amy. Maybe one way that Cooper and I can answer this is, so the question is, how can we do the risk calculus for calling, hospital patients in this case, right? So, today Gridspace is in production with hospital systems where we call patients when they're discharged from hospitals. And the question is, okay, well, how do you manage the risk for something that is, high importance, like talking to a medical patient? There's two halves of this story, which is one, how do we build our bots and our platform to minimize risk? And then two, there's how do you actually measure and think about risk? Maybe Cooper, you could answer the first question, which is how do we minimize risk? And then if you don't mind, I might answer the second question, which is how do we measure it and what is the bar for measuring that risk?
Happy to talk about this because we think about it a lot, and thinking about healthcare is really my favorite thing to do because it is kind of the final frontier or the maximum test of what we can and should do with this technology. But to minimize risk, we'll take several different strategies. They're pretty consistent across healthcare use cases. We'll start with very simple things. Like if it's appropriate, we could have the virtual agent say things like, if you're having an emergency, hang up and dial 911. Perhaps we don't need to do that because perhaps there's enough of a kind of telephone or telephony ecosystem within the clinic, hospital, what have you, that a call could be directly transferred to emergency personnel. In which case, we also have what we call shortcuts, where the virtual agent can always be listening for certain things. And that can be simple as the discharged patient saying something like, oh, this is getting really bad, or I think I'm having an emergency, being really explicit about a sudden acute healthcare need. The virtual agent will always be listening for that and can always take a routing action based on that, like sending the call to a human being who's in the loop or sending it directly to the emergency department. And we will also give opportunities throughout the call in what we call the playbook, which is the virtual agent's guide to the task that they're supposed to be achieving, or broadly the conversation that it is supposed to be having. We can build in little points throughout the conversation where if something that might not be immediately perceived by the patient as an emergency, but is worthy of some sort of healthcare escalation, we could take either a different branch in the conversation based on that to ask follow-up questions, or do another transfer immediately of the call to someone, to some human being, especially qualified to handle with acute healthcare situations. So at the end of the day, what we're doing is managing risk conversationally at the top level, explicitly giving instructions to the patient about how to kind of self-escalate their healthcare needs, ambiently listening for emerging healthcare needs that are emergencies, or doing kind of a business logic applied to healthcare, where if certain values are obtained, certain information is received by the virtual agent, either individual pieces of information or pieces of information that in conjunction kind of sum up to a greater need, we can direct the call in a different direction. So that is all built atop generative AI technology, but we are explicitly managing it in a way that we can be sure that we have addressed all the kinds of risk that may arise when you're dealing with healthcare patients.
Okay, and just to chime in real quick, I guess probably my biggest fear is that I hear that these language models, they make stuff up. So I'm really concerned that when this voice agent makes the call to the patient, I don't want it to just be making stuff up that could be problematic. I guess that's kind of concern number one.
And I'll let Anthony speak to kind of the engineering side of preventing hallucinations, preventing a virtual agent from giving bad information, especially in the highest stakes scenarios, which is healthcare. As the implementer, as the voice user experience designer, or the coach of people who are implementing our virtual agents, there are conversational tools that we can implement to make sure that we're even more robust than we normally are against hallucinations, which we can adjust our failover threshold, which is if the conversation has hit what we might call like a dead end turn, in which the back and forth of the conversation is stalled out, we can choose to dump the call to a waiting human being, or even if there's no human being in the loop, we can have the virtual agent politely decline to progress the conversation and have the whole system make a note that this conversation was a failure and that a human being should follow up. Okay. And what that can capture is those moments of antagonism where a caller might, for fun or for just trying to, game the system, be trying to gain information that they're not supposed to have, or just for their own entertainment, trying to get the bot to say something that it shouldn't. And we're really robust against that. But when it's happening, to prevent against the scenarios where it does happen, we can have the whole entire conversational system of a very low tolerance for people who are not playing ball, people who are trying to cause mischief, and reroute the call, or just even skip over entire portions of the call, where we think if we get bad information or are having no luck getting information in one section of the call, we can skip ahead to other sections of the call and always record a note that the call was incomplete, perhaps because of an antagonistic caller.
How do you even know, though? I mean, how can you tell if someone's trying to trick it or whatever?
Inherently, our system will say if a caller requests information, even if it's benign and totally reasonable request, that we have not authorized the bot to share or provided that information for the bot just to draw upon as needed. Basically, if someone's trying to access forbidden information, even if it's fairly harmless, just out of scope, our virtual agents will say things like, "I'm sorry, I don't have any information about that," or I'm sorry, I'm not permitted to speak on that. They can improvise a little, depending on how much improvisational ability we allow them. But it'll always be a firm indication of, we're not going to talk about that today, because that's outside of the bounds of what I'm here to talk to you about. And when that happens, we are counting a strike against our predetermined kind of failover threshold. So the number of times that a virtual agent has to give that response, "Sorry, I'm not allowed to speak on that," or "I'm not able to speak on that," we're tracking that. And if we hit whatever the predetermined limit is, say it's 4 in a particular use case, then the bot will kind of be ambivalent about why it hit that failover threshold, but know something is going wrong enough that the call needs to be escalated in some way.
Is that pretty robust, though, your ability to get it to contain what the voice agent will respond to? Because I've seen, like, some companies have shown demos where they show a prompt, and the prompt is what tells the agent what it's supposed to do. And in some of the demos that I've seen, the agent will respond at first to questions that it really doesn't have the answer to. And then they'll go back into the prompt and they'll do stuff like they'll say, don't respond to any questions you don't know the answer to. And sometimes that kind of works, but a lot of times it doesn't work. So I'm just curious what you guys do differently to really make that more robust.
Yeah, I'll quickly hand over to Anthony to talk about the engineering significance of this, but I'll speak from kind of the end user perspective, which is it's very nice that prompting is entirely hidden or not exposed to the end user in our system. And prompting in the broad world of generative AI is where things can get a little messy. But what end users of Gridspace virtual agents are presented with is a very orderly and structured map for a conversation, which is flexible to pace depending on the information that's received, the evolving situation of a conversation. But basically a diagram of the allowable conversation is shown, and it'll be very clear that something is a deviation from that because it's just simply not diagrammed out or not allowed in the general instructions as presented visually for the conversation. So it'll be very clear that if something is outside of those bounds, that it will be something that the bot, the virtual agent, will push against, will be resistant against, and will steer away from and try to get back on the main conversational path. But as far as the nuances of prompting and how our system works, I think I'll defer to Anthony on that.
Maybe it would be useful to talk about three things. Like, one, in a little more detail about what hallucinations are, and two, what are the engineering solutions that you can do broadly in the language modeling community to deal with hallucinations, and then specialized solutions that Gridspace can do as a voice technology company that operates in the customer support and call center context. And then we can finally maybe talk a little bit about measurement. So again, hallucinations are just any time a generative model generates unexpected or untruthful output. And hallucination has been kind of coined as that term. There's a fundamental challenge with building language systems that are flexible enough to handle unexpected language generation, but also limited enough so as to prevent giving the user false information. If you are providing a tool that is maybe a little bit more for consumers or entertainment, like ChatGPT, the user is primarily just put into the loop with a language model. So basically, you generate a little bit of text, and then the model generates a little bit of text. You generate a little bit of text. That context does not have very much you can do besides try to align the model to not make things up. One common strategy beyond that, which you mentioned, Amy, is prompt engineering, where you try many different strings with the hope that it might coax the model into being more truthful. And that does work to some extent. A couple other best practices in the state of the art of language modeling that applies to more than just Gridspace are the follows. One is something called RAG, or retrieval augmented generation, in which one prompt is used to generate a query to some sort of data store or index, and then the retrieved information is then reviewed by the language model in the process of generating a response. It does force the model to split up its task into multiple pieces, and does force it to reference grounded information before generating, dramatically improving reliability. In the case of Gridspace, Grace has two different RAG systems. One is called the knowledge base, which is where users upload all their knowledge information or documents for their company. So Grace has a truthful set of information to base her responses on. The second is the coaching mechanism, where episodic memories of past coaching or practice calls are retrieved in context for Grace to reference. Given that Grace can reference all these documents and coaching sessions, that already grounds things quite a bit. Another standard strategy is something called chain of thought reasoning, where you force the model to split its reasoning into multiple steps. This has been a state-of-the-art technique for about 3 years now. In Grace in particular, because it is a call center bot, it really needs to be able to answer questions, route people, and fill out forms. That's it. A lot of the chain of thought has been achieved by breaking the entire dialogue system into sub-modules that do specialized things like generating queries, reading documents, generating responses, filling fields. And by forcing the bot to follow a procedure that in our case is just ordinary software, you force a chain of thought process for which you never have to give the language model a very long leash. Those are the standard state-of-the-art techniques. Beyond that, because Gridspace builds all its own models, its speech recognition, its dialogue system, its synthesis, but also all its language models, we have the privileged position of having a very restricted use application. Doesn't need to write sonnets. It doesn't need to be able to make jokes. It just needs to be able to fill out forms and answer questions. We've aligned or trained our model to say, I don't know, if it doesn't have the information that's lacking. Whereas ChatGPT is aligned to generate long, full answers. Originally, the way they aligned, meaning fine-tuned their model, is they had a large number of people in Kenya rank responses by how high quality they were. And now they have a large enough user base. They also have a lot of user data to use for alignment. But the difference is that alignment tends to be more for quality or length than it is for truthfulness, versus that we can actually fine tune our models to say, I don't have anything from the knowledge base, I don't know. Sometimes we don't even need to rely on the language model to make that decision. We can literally just tell the model, no documents were returned, and then generate the response, I don't know, not from the language model at all. Speaking of which, one of our other specialized components is something called the playbook, which is just a scripted call center inspired system where the users have provided scripts and forms for the bot to follow. If the bot is just reading a script, we don't need to hit a language model to generate that scripted output. We just generate it directly when we have that luxury. Now, if someone asks a question or asks a question about a question, it's just too complicated to generate a response without a language model. But in general, you can 90% reduce that risk by most of the time these calls are routine enough that it doesn't need to generate a bespoke response for every conversation turn. So beyond specialized subsystems, one other unique thing that Gridspace is able to do is detection. So we also have models that specifically look and verify that what you've generated seems reliable given the evidence provided. This is similar to chain of thought reasoning, but it's specialized to the context center use case because we always have the same resources provided to the bot. Or in other words, the bot has been fine-tuned to use the tools we built for the bot. The final thing that we're able to do from the engineering perspective is something called breadcrumbs, which is making Grace reference its sources explicitly in everything it generates. Over time, I think retrieval augmented generation and breadcrumbs have increasingly become a part of general language models like ChatGPT, and we've been delighted to see that. But it's something we've been using much longer than those were in those platforms. However, we have this, again, huge benefit, which is we're not putting the users in the loop of the language model. They're in the loop with a dialogue system that is ordinary software. It's a state machine where we use language models as specialized submodules. I know that's a lot of information, but there's a lot that we've had to do to address hallucinations that we have the luxury of being able to do, both from engineering resources, but by having a restricted use case, which is customer support. Now, I mentioned I was going to talk a little bit about measurement, which is, all of this is for nothing if you aren't actually measuring hallucinations and risk. For the most part, we have a very extensive automated test suite for measuring hallucinations, not just in Gridspace, but in just raw language models, including the ones that we use. And we're actually able to measure explicitly the effect individually of each of these countermeasures that I've talked about. And for the most part, our risk of hallucinations is dramatically reduced in a given call, because when it is using language model to generate a response, it's very restricted to just summarize this document or paraphrase this answer from the knowledge base. But the most important thing that I'd like to emphasize, again, we're talking about healthcare here. Healthcare, we have patients that have just been discharged from the hospital that are, need to pick up their medications, that might have signs of infection, that might not know their discharge instructions. And our virtual agent is the primary point of contact with their medical institution. This is a very important, important use case. But often when people talk about risk of rolling out a new technology, they talk about one-sided risk. They talk about what is the chance that this thing might fail. And I think that one thing that we have found with our customers together is the importance of looking at something called differential risk. So let me give you a metaphor. You are in an airplane. Your risk of dying per 100 million passenger miles is 0.003 deaths. In other words, air travel is very safe, or to me, that feels very safe. And yet it scares a lot of people. It's a lot of people's top fear. It even drives people from flying. But if you're actually looking in a vacuum, okay, what's the chance that I'm going to have an incident flying on this plane? Besides maybe occasional, disasters in the news, it's very, very low. But it's hard to really tell that. Like, what does 0.003 deaths per 100 million miles mean? It doesn't really mean anything to me in terms of analyzing risk. It's hard for me to even really think about that number. But if you compare it to the most likely form of transportation that you're going to substitute flying with is ground transportation. Ground transportation has a risk of 0.57 deaths per 100 million miles, which is about 200 times higher. And so when you look at differential risk, the question you need to be asking is not what is the absolute risk of a failure, but what is the impact of those failures, what is the likelihood, and what is the impact and likelihood of the supplanted risks. Most of the calls that are done in the healthcare industry for us are not replacing existing humans or nurses or doctors. They are calls that these institutions have wanted to do for decades, but did not have the resources to do. And so we are calling patients that otherwise would get no phone call. We're calling people who have lower grades of cardiac risk that before couldn't receive calls. We're calling people with pre-existing conditions that should be receiving regular touch points that the institutions did not have the resources to do those touch points with. And so when you look at what is the risk of rolling out a virtual agent to check on a cardiac patient's condition versus don't call them at all, oftentimes the risk of not doing the call is substantially higher. And so a lot of times you can shine a lot of light on these systems by recognizing from the differential perspective, what are you gaining relative to the status quo? Another example that often comes up for us, not so much in healthcare, is the risk of relatively under-trained new agents handling a call in an unstandardized manner. Many of the call centers that we work with have 15 to 25,000 agents. The average attrition for a call center agent is 18 months. It has the lowest job satisfaction of any job in the United States, and there's over 3 million people working in that sector. And a lot of times the result of that is that the average person in a call center is very undertrained relative to the complexity of their job. And so one of the reasons that businesses for 15, 20 years have been trying to move their customers to digital channels is they are controlled. They all see the exact same website, the exact same web form with the exact same text, reducing risk substantially. By contrast, if you're a financial institution like many of our customers, not only are you presenting a slightly different experience every time, but you're also having those people handle PCI or PII data, social security numbers, credit card numbers over the phone hundreds of millions of times per day for maybe just one financial institution. So when you start to do that risk calculus, when you think about it differentially, what you're doing is you're standardizing the experience and you're doing calls that you could not have done before, substantially reducing risk. And in my opinion, that it's obvious, it's easy to pick at ChatGPT and say, I would not have my customers talk to this. That is the correct thing to do. There's a lot of engineering that goes into making this system safe. But when you actually measure the risk of what we're deploying, the finding is not that it is safe enough to use, but that it is, with this technology now at this level of maturity, it is deeply unsafe, probably not to start to roll these systems out sooner rather than later.
Yeah, that's a really good point. So a couple of things that you said, again, with my role-playing hat on, I have talked to and seen a lot of other vendors that are offering kind of voice agent capability, and pretty much all of them are using some, let's call it state-of-the-art model created by some other company. It's a lot of times it's going to be OpenAI. It might be something from Google. It might be something from whomever, even like an open source thing that they have fine-tuned or whatever. But it seems like if I'm making a decision on what company to go with, there's something in me that says, all right, I would almost rather go with a company that is using one of these state-of-the-art models, because I have heard that those models have really been trained to be safe. There are safeguards built into them, right? But now you're saying that you have built your own model, which is intriguing to me because I haven't really heard most people saying that they have done that. But I'm also concerned because then I would think like, well, what are my risks of using your model? Does it have safeguards built in? And then the other thing, I guess, which is a little bit different, would be, well, if I'm using your model, is your model like state of the art? Am I going to be getting all like the great stuff that will be getting if I use one of these newer models?
Yeah, I mean, so Gridspace has been a leader in the fundamentals of speech and language technology since our founding. We came out of Siri, SRI, the lab that created Siri and Nuance. In general, we have our team is composed of world experts from Stanford and MIT in speech and language processing. Voice is very different than text in that people can interrupt each other. They rely on prosody and tone for meeting, and it's also very high value for that reason. Our ethos has always been to build state-of-the-art models beyond what's in academia or industry. In general, some of the newer players in the space, like OpenAI, they are focused on, essentially mega projects of scaling up language models or vision models. And there's a lot of value provided there, but a lot of that value, has been replicated in academia relatively quickly with models like Llama. Our focus has always been the product problems of how do you actually build a useful, reliable voice system that can be deployed at scale. Gridspace right now processes several billion minutes of speech data a year, which is more than probably every other AI company in the world combined. And then we also build all our models. We teach speech model development at Stanford and MIT. If you want to know what's state of the art, you come to us first. We have been the ones. It's a small space. Speech, especially conversational speech, is not a big space, but it is a space that we have been leading in for quite some time. I think there's a lot to learn from the progress in the mega projects like ChatGPT or GPT, or other large foundational model developers in terms of how people interact with these systems and what people's expectations are. But if there's one thing that you've really learned, is something that I think people in the language model community have known for a lot longer than ChatGPT has been out, which is that just treating a language model like it is a dialogue system or treating it like it's a person is not a responsible way to architect a functional commercial enterprise system. And that's something that we've been educating the market on for a couple of years ourselves, which is that one, you have the responsibility to build all your own models and deploy them, one, so that you can control the experience for safety reasons, but also because we have this very large compliance boundary need. We have we're beholden to for healthcare, iTrust and HIPAA, for financial services, SOC and PCI. And so we have a legal responsibility to control all our user data in a certified environment, which means we can't use external APIs like OpenAI's APIs or anyone else's. And we also have to build our model specifically for those use cases. So our form filling model needs to actually check that it's a valid credit card number if you're collecting a payment information, for instance. And so in general, I think that when people are asking, okay, how do I know that X is state-of-the-art, Gridspace, OpenAI, whatever, at the end of the day, the most important thing is if you have a problem, it's our responsibility to show you that we're solving it to your satisfaction. If there's any concern beyond that about our ability to be at the state of the art, I think that there's plenty of evidence to that perspective externally. But to be honest, I care most about your problem as an institution, whether you're a hospital or a clinic or a medical call center, or you're a oil and gas company calling people payment reminders, like whatever it might be, that if we're solving what you need us to solve and you feel satisfied, the hope that I have is that you don't care if it's AI or not, because the truth is, we try to solve things in the most reliable, inspectable, consistent way possible, and only rely on more increasingly sophisticated models when it's a necessity, versus just trying to first and forward always show the fanciest models 100% of the time. Like our biggest language models are just used for certain language generation. We don't use it for everything that the model does, because we know that can result in a cooler experience and a more fun experience. It's more flexible, marginally, but to an undeniable extent. It's when you talk to just a language model like ChatGPT, it really feels as maximally human, but you are maxing out risk and completely taking away the user's ability to control the system. All our users that build bots with Grace are filling out our playbooks, our knowledge base, are doing coaching sessions. We give them all these tools that the models are built for that don't exist with ChatGPT. ChatGPT doesn't give you any enterprise tools for building a bot. They just give you a bot. The only thing you really do is prompt it. And so, then a lot of the GPT wrapper companies are wrestling with that. They have almost no control over these models. And so even if, OpenAI is, 3 months ahead of llama or something. When it comes to speech, which is more complicated, and enterprise, which has a much higher bar, I don't think there's anyone else really quite doing what we're doing. There's a renewed interest in the space. When we would talk to people 3 years ago about language models, they could be very technical and have no idea what we're talking about. Now we have people asking us about RAG and hallucination management, which is a delight, because I wouldn't have been able to fathom before ChatGPT that the market would be so educated as they are now. But that only increases our responsibility to not only educate our customers about what they're expecting, but also a lot of times our customers have relied on us as a strategic asset or counselor on their generative AI strategy broadly. Because we're not the only, voice is only one piece of the puzzle for people in terms of rolling out AI technology. And so, we often give them our trust and safety guidelines, which has our rules of the road for generative AI. Everything I just talked about with regards to hallucination being just one point of many in terms of how you build systems that are safe and reliable.
So let's say that I'm convinced now that Grace is going to be fine interacting with my patients. I'm not concerned about what she is going to say or go off rails or whatever. But now my question is about the data. So in interacting with the voice agent, a lot of data is being collected. First of all, I want to make sure that I know that the data is accurate. And then also the other big question, which we could probably spend a lot of time on, is how can I make sure that data is secure? Do you use any of that data? And then like training your models, and do I still own the data? What about those types of things?
When a virtual agent for Gridspace is collecting information, we typically do it through highly structured form fields, which are available from a drop-down menu, very accessible to the end user. But there are native behaviors to the collection of values for each form field that have a lot of checks built in. So if we're looking for a credit card number, for example, one of the most sensitive pieces of information, we'll be looking for a correct number of digits, correct formatting, and then collecting types of dates. There will be behaviors to reject dates that are impossible. Like if you ask for a date of birth and someone's having a laugh and just suggests a date that's in the future, that kind of thing will be automatically rejected. And that's up to our models, knowing that certain types of information or certain values are out of bounds for any given form field.
So just to make sure I understand, so you're saying that even though I'm getting a voice call from the agent, I will see the form on my phone or something to fill out? Or
great question, but to be clear, these are form fields are contained within what the playbook that we previously mentioned.
Oh, okay.
Which is the general structure for the conversation. So the virtual agent is looking to obtain very specific values as prescribed by whoever the designer of the virtual agent was. And there is a lot of automated behavior that just is native to the virtual agent that the end user does not need to specify, that it will be very robust against certain unacceptable values for any form field value that it is looking to collect. And that will also include on a higher level within the virtual agent. Virtual agent can recognize that it probably didn't hear everything correctly. So if there's an ASR error, an automatic speech recognition error, arising from just the speaker speaking unclearly, or perhaps a truck rumbles by in the background, if for that reason the unacceptable or incomplete value for the form field is collected, the virtual agent is smart enough to politely try again. But then there are other, we can think very carefully about, what the standards are for any particular use case, whether the virtual agent is replicating a use case that already exists that humans do in the world and supplementing human power, or if this is a novel use case that humans have never been available to do before. Just designing the system and making it robust allows us to put in double checks. We could insert a form field where we collect a piece of data that is checked against something that is already known about the caller, especially if we've made an outbound call to someone whose identity we already know, and to see if things are aligning based on that one known value. And if there's a discrepancy between the known value and what is collected, we could handle the call a different way, perhaps flag it as perhaps unreliable information or send it to a human being, whatever we want to do. And then we also have the ability to set form fields, values that we're looking to collect from a human being as optional or not. And generally the guideline is that if we're having a virtual agent ask for a piece of information, it's an essential piece of information, at least for the use case, because why else would we bother doing this? But there are circumstances where we want to maybe allow for someone feeling very uncomfortable sharing a certain information over the phone, regardless of whether they're speaking to a human or a virtual agent. In which case, rather than, like making it mandatory and either abandoning the call or compelling someone, giving someone an incentive to maybe provide inaccurate information, if someone says, just don't want to tell you that, or we can skip that, or maybe I'll share that at a later date, the conversation, the virtual agent is permitted to skip over that information. And in the analytics for the call campaign or all the inbound calls, we will see that there is a null value collected, or rather a null value exists in that form field, which should be a flag that that needs to be collected in the future, or maybe there was some discomfort from the user about providing that information. So native behaviors from the virtual agent for making sure that information collected is correctly formatted, meets expectations about a certain value. You can check against a ground truth value just to make sure that things are generally on track. And then we also can build in some leeway for the human on the other end of the phone to decline to answer in circumstances where they might have been incentivized to answer less than truthfully or evasively.
I mean, it's kind of cool the way it works too, from what I've seen, is that you really just have to have the form and maybe some kind of prompt that you create, but that the agent then knows which questions it still needs to ask, which ones maybe weren't answered. Like you said before, if it didn't quite understand it, it will go back and ask again, but none of that stuff has to be like hard coded, right? I mean, it just kind of is smart enough to know that it needs to do whatever is required conversationally to gather all the information required for the form.
That's true. And I'll steer very far away from the phrase hard coded, but we could, with thoughtful design of the conversation, we could give explicit instructions to our virtual agent if we were getting very ambitious, say like, okay, we've reached the end of the call. But if we check now and see if there are any values we were not able to collect because the user declined earlier in the call, maybe let's loop back and try again, because it's just a principle of appropriate conversation design, even humans to human speaking, that people tend to warm up the longer a conversation goes on. So if we wanted to say like, hey, I know you didn't want to answer this earlier, but if you're feeling better now, do you think maybe you want to tell me the last 4 of your SSN or confirm your street address for me? We could explicitly design in loops in the conversation like that. And it's not hard-coded, doesn't really require any technical know-how. It bears a very close analog to just human contact center agent scripts, where we want to standardize an experience if a human is speaking to a human, such that customer service maintains a certain level, and that there are no weird edge cases where someone is mistreated or given reason to doubt the credibility or safety of the agent that they're speaking to. So basically, we could add in directions to the virtual agent to reattempt portions of the script, which is something that we'd feel very, very comfortable giving to a human agent as well. It's just like an asterisk at the end of the scheduled conversation being like, if this didn't go well earlier, maybe give that another try.
Yeah. Okay. Yeah, that makes sense. So I think we also had the question about the data, like the data that you capture. Let's say some of it is even HIPAA data. Do you have a way to manage that according to the rules? And do I need to have any kind of concern that my data might leak out or be shared or whatever?
Yeah, so I mean, in general, our data security best practices are similar to any other SaaS product where, per the provisions of PCI SOC and high trust, in general, encryption at rest and encryption at in transit, best practices for things like authentication, and permission management. All the standard best practices for cybersecurity. In a containerized, scaled environment like we operate in. I think in general we store large amounts of data because we have large numbers of historic calls that we store recordings of, and so also data security for things like cloud storage is particularly important for us. But otherwise, it's very similar to any other SaaS web app.
And in terms of continuous monitoring, what kind of tools would I be provided with so I can see how many calls is this thing making? How accurate is it in terms of getting information back, filling out the forms? Any types of, you had said that maybe there's some flags where this conversation hit a certain failure threshold, so I could see like how many of those failure thresholds are being surpassed. Do you have any dashboards or whatever that we could take advantage of?
In general, Gridspace actually started in analyzing just human-to-human speech, and today, still the majority of the data we analyze is human-to-human speech, and that put us at this immense advantage for providing surveillance and observability for our virtual agents, because we already had a full analytics platform out that has quality assurance, search, the ability to see scorecards over time. We have a general question answering system where a language model can answer questions about the bot, like did it do, how many of the bot conversations went well or needed improvement. So we had a full analytics voice platform that works for humans and bots before Grace even went to market. We had this huge advantage from the beginning from the analytics perspective. Over time, one thing we've learned is that, if your company has never rolled out a generative AI product to your customers or patients or whomever members, and voice is going to end up being the first with Gridspace, most of that time is getting the organization comfortable to roll out use case one. Once use case one is in production, use case two comes quickly. And so getting everybody comfortable is essentially the name of the game. And so one thing we've learned over time, just seeing what matters to people and what makes people comfortable. I mean, one, it's kind of obvious, but the ability to just listen to calls, which obviously we provide a recording of every call, or just read the transcripts and skim the calls. But the second thing is just getting statistics on how many of the calls go to completion versus the person hanging up or you needing to be escalated, what's called the containment rate. And so reporting those statistics to users is part of the platform as well. And then the third is often mechanical analytics about things like telephony. So we also build our own telephony, and we have a platform that has auto dialers and telephony call flows that also has its own analytics dashboards where you can see things like how many people hang up, how many people went to voicemail, all of which, they might not be AI related, but they're a big part of becoming comfortable with rolling out a platform like this. And so, and we just happen to be in a very lucky position where not only were we head on speech tech, but we were head on analytics specifically.
So I have another question, I guess one last question. So let's say I put on a different hat. I am part of a large call center, and we're looking to have a self-service voice agent for the call center. But we do a lot of different things. So there could be all kinds of possible, let's say, workflows, use cases, intents, whatever you want to call them. If I come to talk to you and I'm like, all right, I would like to create a self-service capability where we can elevate the customer experience by letting them do a lot of things on their own. But at the same time, I would also like to do some, call deflection or whatever, so that the agents can work on more high value types of interactions. My question to you is, where do I start? Because how do I even know whether your solution has the capability to handle like all the stuff that my customers might require? And then I don't even know where, should I start with like one intent, or how do I map all that out? And then you've got these playbooks, and do I need to create like a zillion of them? So like what's step number 1 or 2, I guess? I
think you implicitly gave a hint to my personal step 1 already, which is you were talking about leaving human agents for the more high value tasks, either because it requires a tremendous degree of humanity, empathy, emotion, or complex reasoning. So kind of doing a quick calculation of a contact center's most frequent low-value tasks. What's the greatest number of human agent minutes that we could save by having something uncomplicated handed off to a Grace virtual agent, which could, run an almost unlimited concurrency, intercepting these calls or these portions of calls and preventing tying up human agents. So really looking at the areas where you stand to save the greatest amount of human power is probably step one. And ideally that might be a short list, more than one step or use case or sub use case. And then from there, narrowing it down to the first one to attempt in a pilot to get used to is the one where the virtual agent can shine the most. So it normally is the case that a particular use case to start with to integrate into the ecosystem of the call center just jumps out. Like this is very simple, straight down the middle data collection, which includes authentication and verification, where especially if a known customer is calling in from a known phone number, we can map that immediately to who is probably calling, then checking against 2 to 3 more pieces of information that they provide to verify their identity. That'd be very boring and below the skills of most human contact center agents, but a virtual agent will do it by the book, will do it infinitely, and will never get bored. So usually something that stands to save a lot of human power and is a very simple task jumps right out. And it's usually pretty clear where a good place to begin is. And then as the contact center ecosystem becomes very accustomed to having a virtual agent among its workforce, and the other human agents can breathe a sigh of relief knowing that some of the tedium is handled by a current state-of-the-art generative AI virtual agent, more use cases are easier and easier to implement, where the bot is given greater responsibility or flavors of the same use case just applied slightly differently.
That sounds good. When can I start? You had mentioned that you're using like chain of thought as one of the ways to try to reduce hallucinations. And I've been watching a lot of videos and stuff lately about all these new reasoning models. O3 came out, and then there was the big DeepSeek R1 thing. I mean, since you were doing a voice interaction, I was kind of surprised that you said chain of thought, because I always assumed that with something that's more reasoning or chain of thought, it's going to take a lot more tokens and a lot more time, and the latency is going to be increased. So I guess one of the questions was, am I wrong? And then I'm just curious what you think about all of these new reasoning things that are coming out.
Yeah, that's a good question. So, I mean, first of all, we are always extremely latency constrained. As opposed to like a text conversation where you can take 10 seconds, whatever, or more, for us, we have to have speech to text, the language understanding, the dialogue system, language generation, and speech synthesis all happen in like half a second. And so as a result, everything that we do is highly engineered for latency. Chain of thought's been around for a pretty long time, at least since 2021. Okay. And in general, anytime where a language model has things split into steps so that the language model has to do less at a time, is a form of chain of thought reasoning. For us, that tends to take the form of a language model deciding what information it needs, whether to generate a query, whether to consult a playbook, receiving all that information, then rectifying that is broken up into these sub-steps that are being done by different language models.
Okay.
What you've seen in the news recently with like O1, O3 and DeepSeek is also a type of chain of thought that we've seen for a while, where the models are aligned to state their reasoning. Again, chain of thought's been around for a couple of years. I think what they are seeing is they were able to align the model to explicitly not share intermediate generations, and then further align the model through reinforcement learning against problems like math problems where there's an explicit correct answer. And so by first emitting specialized tokens where this is my thinking period, this is my output, and then special tokens for here's the boxed answer that I can do reinforcement learning against, that allowed them to not just have a better chain of thought reasoning through prompting, which is traditionally how it's been done, but rather to align the model to implicitly do better reasoning. And without needing to do something like search, which is something that's been discussed for a couple of years as an alternative to just linear chain of thought. And so what they've shown, though, is the importance of chain of thought to correctness, and whether it's a procedure, because you could just, one way to do chain of thought is by giving the bot a procedure where the procedure walks you through your reasoning. And, think of like a worksheet or like if you're doing your taxes or something,
Right.
that's a form of, as essentially chain of thought, but where you're walking either the person or the machine through a process. We do that in part with playbooks too, where you're giving the bot a procedure rather than letting it organically decide its plan and then follow its plan. Yeah, because if we were to have the bot think for 30 seconds doing chain of thought, that's just not possible. Obviously they say think before you speak, and so there's a little bit of truth to that, which is to say make sure the bot verifies its information before continuing. But we don't have the time or latency budget to spend on like a 30-second generated chain of thought period. But that's really honestly being used right now to deal with like state-of-the-art performance of things like math problems, which language models historically have been ill-suited for. Where I think that'll be showing up more and more in our models is more on our analytics side, where we don't have as many latency constraints. So from we were talking earlier about observability, our models that are used for question answering about calls, whether they be human or bot, are going to get better through better chain of thought models, more like you've seen with like O1 or DeepSeek.
Okay. I do actually have one more question if we have time. I'm curious because I've recently seen different examples of types of prompts. And some of the prompts I've seen are just like very structured. It's almost very prescribed. Like, this is the task, and if you get this response, then the next thing you should do is that, like, you have 5 things. I want you to do 5 things, and the first one is this, but only if you get this information should you go to number 2. But if for some reason you don't get this information, then skip to number 3. It's like it's all in the prompt. And so I was kind of confused by that, and now I'm thinking maybe that's where your playbooks come in, because they're outlining in a much more foolproof way than just putting everything into a prompt. You're basically guiding and instructing the model where it needs to go, what it needs to do next, instead of like having all that stuff shoved in a prompt. I mean,
that's funny, Amy. We were just talking about this internally at Gridspace earlier today, and what you're talking about is something called prompt creep, where it's you don't control your models maybe, but you can just control your prompt, and all you can do is just keep adding and adding and adding to it, giving it more and more instructions until you hope that it eventually does what you want it to do.
Right.
And these models increasingly have 8,000 token plus context, so they can consume these huge prompts before generating their own output. The problem is, in general, prompts should really be a tool of last resort. And if you are going to prompt your language model, you have to give it some input so that it generates an output prompted on something. But ideally, you are aligning your model to expect a certain input. If you control your language model, you should train the model to expect a certain input, and then align it to generate a certain output format. ChatGPT has been essentially aligned to dialogue to generate informative long form responses with bullet points and numbers. That's how that model has been aligned, because it's been aligned to chit chat. But if you have a specialized model that's meant to just do query generation for a RAG system, it needs to be aligned to not just generate contextually useful queries, like for information that's going to help answer a question, but it needs to know what input and output format it's needed, what the format is of the input that's going to drive its query, and then the format of a query that will be accepted by the search system. And so, so prompts obviously are important, but typically you're going to have ideally a really structured prompt that your model has been trained against, instead of prompt creep, where you just try to have this massive, like you said, business logic and tons of information. You're essentially in natural language trying to explain what should be done in software. And you're left with no resort, because you're leaning on the language model to do this complex behavior, but because you don't control the training of the model, the data used in the model, anything about the decoding process. You're very limited in your tool set if you're just building on top of language models. And that's one thing a lot of, especially wrapper companies, are learning the hard way, which is language models are incredible technology, but they're not sentient, they're not organisms, and they also are not software, right? Or they are software, but they're not rule-based software. They are
Right. They have to have some guidance. Yeah.
They're a statistical model of next token prediction, and that's all they will ever be. And so if you don't treat them that way, you treat them like they're magic or like they're a person, and then you just keep trying things, you might get it to work some of the time, but you're never going to have the guarantees you need for an enterprise situation. And everyone's been learning this the hard way, even though, language models, statistical language models have existed since the 1970s. And this applies to any language model, not just like a modern large language model with 100 billion parameters or something, but it's just true about language modeling in general. And so I think that prompt engineering, it's an important part of the process, but it has to be treated as your final step, as a cherry on top. It can't be your starting point if you want to do something that's reliable.
The prompt and how you manage the prompt, and if there is prompt creep and all that, that does circle back to the theme of trust and safety, because there could be a lot of problems. If your security is based on your prompt technique, that's probably not a very good strategy. So yeah, thanks, Gridspace people. It was a fun conversation. I know that there's a lot of information on your website. I believe you can even interact with Grace there, and you can also get some examples of how these playbooks work. I think that's a fun place for people to go to get more information on that. We're going to have another chat, and then with I think my colleague Derek Top is going to be discussing with you guys the topic of generative AI return on investment, which is always top of mind with people. So I look forward to that discussion, and yeah, I'd like to see you again next time. Thanks.